Hi, good morning. I had a request for a video about simplifying radicals, simplifying square roots. And I thought, you know what, I'll just go ahead and make my own since YouTube didn't seem to have, they had such a variety that I could make it easier. And actually, I don't have a song for you on this one. So let me go ahead and share my screen. I want to go back to these notes that I did on day 2 in August of 2004. And I call it the Radical 70's. You don't have access to this file, but maybe I can put it on the internet, but that's not really important. I need you to know that the square root of 1 is 1, the square root of 4 is 2, the square root of 9 is 3, the square root of 16 is 4, the square root of 25 is 5. And again, this might not look like a square root because that bar is over, but these were old notes, okay? The square root of 36 is 6, the square root of 49 is 7, the square root of 64 is 8, the square root of 81 is 9, the square root of 100 is 10, 121 has a square root of an 11, 144 has a square root of 12. And then there's more than that. There's more what we call perfect square numbers. And you might be familiar with those, but what happens if we don't have a number that happens to be a perfect square? So a long time ago, I came up with this crazy, crazy situation where I said, let me show you how to simplify radicals Komenchek's way. And I call it the radical 70's. I grew up in that time, and I don't want to be mentioning, war and protests or stuff like that, but this is just for fun with respect to trying to get you to simplify radicals and not think of it maybe in a mathematical sense. So I'd like you to listen to my comments on radicals, prisons, lawyers, a waste of taxpayers' money, and rationalizing, etc. So, and these are called, what I say, simplifying the following, leaving answers in exact radical form. And I'm going to be doing this on a whiteboard, these problems on a whiteboard, but I wanted to show you, first of all, let me stop sharing for a second. I want to show you what I wore in 2004 and years after that. What I wear is I have this shirt. It's got a big peace symbol on it. Let me see if I can get it up here in the view. Stand up a little bit. Okay. And this peace symbol was representative in the early 70's. And because we wanted peace, we were kind of like hippies at that time. And so what I want to do is talk to you about those hippies and what happened to them. The hippies were really, really, really nice people. Okay. They just, maybe they smoked too much, a little bit marijuana, but they were really loving people. That's where I first learned to play a guitar and create songs. And one of the songs we were always sing is, all we are saying is give peace a chance. Well, what happened lots of times is some radicals, even though they were great people, nice people, they got a little crazy sometimes, and they ended up, excuse me for a moment while I change outfits. And yes, when I was in the classroom, I actually got this outfit on. And sometimes radicals, nice people, okay, were put in prison. So what I'll need to do is tell you what we're going to do with these nice people who happen to be in prison. And again, we call them radicals. Okay, so let me pass them so I can share my screen. So you know that the square root of 9 happens to be 3. Well, this square root, I'm going to call a radical now, and, because that's what sometimes we call it instead of the square root. What happens if I have the square root of 8, and 8 isn't a perfect square, but you're asked to simplify that radical completely? Well, what you could do is you can do it the way I've been doing it in class, as to factor 8 into 4 times 2. And then the square root of 4 happens to be 2. And this square root, this 2 is still left in the square root for 2 radical 2, or 2 square root of 2 is your answer. And this is called the simplified radical form that represents square root of 8. If I have, I believe we did this in class, radical 32. Some people's most favorite factors for 32 happens to be 4 times 8. And the square root of 4 is 2, but then you still have square root of 8. And then we need to simplify square root of 8, but we know square root of 8 is 2 radical 2. So this is a 2 times a 2 radical 2. And so our final simplified answer would be 4 radical 2. But a better factoring for 32 instead of 4 times 8 would actually be, if you want to get more directly to the answer, 4 radical 2 is the answer, is to factor it into 16 times 2. Because the square root of 16 is 4, and this 2 stays in a radical. And that's exactly how I presented in class, but I've got a little bit of a different way because I want to talk to you about radicals and prisms. So this again is called a radical, and another way I could represent it is as a prism. Hence I dressed up in the prison outfit. Okay, so let me show you another way that you could consider the square root of 9. The square root of 9 can be factored. 9 can be factored into 3 times 3. And what I'm going to do is I'm going to say that you happen to be a 3. And your lawyer happens to look exactly the same as you. And that lawyer helps you get out of prison, because this is the prison. And so you get to come out of prison. And so the square root, as long as you have a lawyer, you get to come out of prison. And so you, who's the 3, comes out of prison. And what happens to this lawyer? He disappears with your money. But the square root of 9 is 3, which is something I hope you do know already. But what we could do is we could actually go and say 3 times 3, you have a lawyer, you get to come out of prison. This is you. Well, how does that relate to square root of 8? If you wanted to factor the square root of 8 into the fact that you know that this is 2 times 2 times 2, if you look real carefully at this, if you consider this is you, and this is you, this is your lawyer, and there's somebody else here in prison with you. That you, who is a 2, get to come out of prison because your lawyer came in to get you out. So you come out of the prison, you go out in front, but this guy has to stay inside prison, and that gives you the same answer that it does here. When you go 2 times 2 times 2, that's called prime factoring because you can't factor it any further. And again, you don't have to do it this way, but it's one way of trying to simplify radicals for those of you who might have some difficulty. So let me go to erase this for a second and put another problem on here. What if we have the square root of 108? Now, 108 is a really large number that I don't know too many of the factors, but I know I can divide it by 2. I happen to know that that's 2 times 54. But since neither of these has a lawyer, what I can do is I can continue factoring on the 54. And my favorite factors of 54 are actually 9 times 6. And now I'm going to factor completely going down to prime numbers, those which can't be factored any further. This is 2. 9 is written as 3 times 3. And 6 can be written as 2 times 3. So let's see who you happen to be and who your lawyer happens to be. So if you consider this 2 as you and somebody who looks exactly like you is over here, we'll call him your lawyer. That means you, who is the 2, get to come out of prison. Out of prison here. What happens though is, let's see, we got that, we got that, we got that. This 3, who could you consider you, also has a lawyer right here. Looks exactly like him. So you, who is the 3, get to come out of prison. And everything here is multiplied when you come out, you multiply. And who's left inside the radical is 3. So in simplifying square root 108, rather than even going to any primes at all, or, you know, what's my favorite, the perfect square here, we're going to simplify that as 6 radical 3. Now I'm going to pull up, let me share my screen with something else for a second. I want to pull up my Casio calculator and show you. I have turned it on and I'm in what's called run mode. Actually, let me go to the gray menu key. When you turn on the Casio, you get this screen, which has lots of different capabilities. I can graph, I can do dynamic movement of graph, I can solve equations, but I want to do some run mode. And so I've got the run mode highlighted and I just go ahead and enter it by pushing this execute key. The square root button or the radical button is found here by shifting square root. So if I go ahead and shift the square root of 9, I do expect to get 3. Older calculators cannot do this, but our new calculators can. And remember, I just did 108. And if I push this execute key, it actually gives me the answer in simplified radical form. So this is one reason why I really can't use, you really are not allowed to use calculators on simplifying your radicals because they can do it for you. And I'd really like you to be able to do that without. So let me go back to this. Calculator should only be used, in my opinion, to verify what we already can do by hand. It's not a door stopper. It's not going to hold the door open for you as you go in. It's going to not do the work for you is what I mean. Let me go back to my whiteboard. So 108, 6 radical 3. Larry. We're probably not going to have to do this in our case, but what if we have a 5 radical 72? Because we can have people outside of prison and people inside of prison. If your favorite factors of 72 happen to be 9 times 8, you can go and simplify radicals your own way, but you could also simplify radicals by factoring completely. This is 3 times 3. This is 2 times 2 times 2. 3 has a lawyer. 3 gets to come out. 2 has a lawyer. He gets to come out. And so what do you do with all these numbers that are coming out? They all get multiplied because the only way they could come out is if they were all multiplied. And so we have 6 times 5, which is 30 here. But we still have somebody left in prison, which is the 2. So our answer is 30 radical 2, and that simplifies this radical that had a 5 in front of our prison. Okay, next example. Again, we will not have problems like this in our current class, but if I gave you the square root of, let's say, let me do something nice. The square root of 6 times the square root of 24. I call this a waste of taxpayers' money, and I say, why do you have 2 prisons when why don't you just go ahead and put them both in the same prison? And when I have a problem like this, what I would actually do is I would actually not go all the way to prime numbers, because I notice that 6 happens to be a factor of 24. I could make this 6 times 4. And now this 6 can come out of prison. So I don't have to go down to prime. I just have to go down to where you actually have a lawyer. I do notice that 4 can be simplified. So again, I'm not going to go prime here. The 6 gets to come out of prison. 2 gets to come out of prison. And there's nobody left inside prison. So our simplified answer on this is going to be 12. Again, if you do multiply 6 times 24, because you're so inclined to multiply that, you get 144. And the square root of 144 is going to be 12. So you could do it more directly with your perfect square numbers, or you could just go ahead and use this prison method if that works better for you. Again, we're not going to have this situation, but what happens if I have the square root of 5 times the square root of 5? Again, I call this a waste of taxpayers' money. Why have 2 prisons when you can throw them both in the same prison? And yes, you could multiply that together to get 25, but if you look carefully, you've got your lawyer, you get to come out of prison and nobody's left inside prison. So this essentially is just the square root of 5 times the square root of 5 is the square root of 25, and the square root of 25 is 5. And you can use that pulling somebody out of prison by having your lawyer help you in a little bit. We also have something, and again, we're not going to work on this with respect to in our class, but just to go higher, what if I have a 3 in the index of my prison, and I've got a, let's say, a 40 in here, and I'll put some variables in here. I'll go x to the 5th power. When we have the regular old radical, the index here, which is not written, is supposed to be a 2. That's why we call it a square root. You have to have 2 people alike to come out of prison. Well, in a problem like this, I'm going to call this a high security prison, you need more than just a lawyer to come out. Let's go ahead and factor. That's supposed to be a 3. Let's go ahead and factor 40. I'm going to do 8 times 5. Watch how I'm going to write 8. We do x to the 5th power as x times x times x times x times x. And in this case, with this high security, with that index of 3, we need to have more than just the lawyer. So what I'm going to do is this, I'm going to say, here's you, here is your lawyer, but that's not good enough in order to get you out of this high security prison. You also need to have the judge on your side. So we're going to call this the judge. So who gets to come out of prison? You do. And when you come out of the prison, you're the 2. The lawyer and the judge disappear. You still have this prison left, but let's see if anybody else can come out of prison. The 5 can't. He doesn't have a lawyer. He doesn't have a judge. He doesn't have anything. He can't come out. But look at these X's. If you consider you here, your lawyer, and then the judge, this X gets to come out of prison. This X times X cannot come out of prison because it's high security. And we would leave that in simplified radical form. And your calculator does not do that. So, and again, that 3 should be in the index. That's not an X cubed. It's the 3 it's supposed to be in the index there. Okay. What if we have a situation where we have a square root of 72 in the numerator of a fraction, and we have the square root of 8 in the denominator of a fraction? I again call that a waste of taxpayers' money. And I say, throw them both in the same prison, but the 72 has to stay on the upper floor and the 8 has to stay in the lower floor, in the basement. There's several things I can do here, and I don't like to think about canceling people out in prison. So I'll just say we'll reduce the prison population because 72 divided by 8 is actually 9. And now that I have the square root of 9, I know that that answer is 3. I hope you know that answer is 3. But if you'd like to write yourself down as prime factor so you can see your lawyer, you have your lawyer, you get to come out of prison. And so that simplified square root of 72 over the square root of 8 is just going to be 3. If I happen to have, let's say, let me get my notes out. If I now happen to have the square root of 27 added to the square root of 75, I cannot add these together because they're not like terms, but let's look at our numbers inside each radical, inside each prison. Since 27 can be written as 9 times 3, and 75 can be written as 25 times 3. You can see that this 3 has a lawyer, so he gets to come out of prison, but this 3 doesn't have a lawyer, so he has to stay inside. This is a square root right here. Index is 2, just not written. And this 5 has a lawyer. He gets to come out of prison, but that 3 has to stay in. Now we have what are called like terms. We have a 3 radical 3 and a 5 radical 3, and we can add them together because they're like terms. Or you could consider perhaps factoring out the greatest common factor if you are not comfortable with adding those together. If we factor out the radical 3, you have 3 plus 5, which ends up giving you your final answer of 8 radical 3. And I always write the people outside of prison first, rather than writing this as radical 3 times 8, which is what this looks like. Because if I'm getting a little sloppy, if I'm trying to read your works, I have to make sure this 8 is outside of prison. So I always put everybody outside of prison in the front. Let me go back to my notes. So I've done several examples on here, and now I've talked about addition. I didn't talk about the subtraction, but it's very similar. But I now want to talk to you about the rats. Rats, oh rats, oh rats. So let me stop sharing for a second. Here, this is what I normally have in the classroom. You know, it's an ugly old looking rat, but this is what I have in order to try to emphasize the fact that we're in prison, and guess what happens in prison? There's rats. But there's some good news. Oh, actually, let me show you while I'm here. Yeah, let me show you the notes first. I thought that was a cute picture. So we have to deal with situations where we want to be kind and benevolent to all these radicals who happen to be in prison, but we don't want them to deal with rats. So here's what I say. When simplifying a radical expression, we're going to write the expression in such a way so that there is no radical in the denominator. Sometimes you can do this by division, by canceling within the prison system. Like in the previous example, I had the square root of 72 over the square root of 8. However, a more general method is to multiply the numerator and denominator by the same thing, equivalent to multiplying the fraction by 1 so the value is unchanged. This procedure is called rationalizing the denominator. So I know that was a lot to take in, but I want to talk to you about these next few situations where there happened to be somebody in prison in the bottom floor. So I'm going to talk about 5 square root of 6 next, 6 over square root of 2, and several of these where people might be left in prison in the basement where the rats are. Okay, so let me go share the whiteboard with you. Again, the first problem that I had that I mentioned had a 5 in the numerator, not in prison, but this 6 is in prison. You cannot get this guy out of prison. He doesn't have a lawyer. Even if you factor him with 2 times 3, he's not going to be able to come out of prison. But there's rats down here. And so I will try to draw a nice little rat here with the tail and nose. As the bird. But anyway, he's a rat. What we want to do here is we want to do what's called rationalizing the denominator. However, since you can't come out of prison, you can't change a problem just because you don't like the way it looks because of those rats. What we are allowed to do is multiply this by some form of 1. If you multiply by 1, you don't change its value. So if I multiply the numerator and denominator by a special form of 1, which is going to be radical 6 over radical 6, because this is some form of 1. What you're going to have in the numerator, one big numerator, you're going to have the 5 not in prison. The 6 is still in prison. It just happens to be in the numerator up in the top floor. This is a waste of taxpayers' money, or hopefully by now you know the radical 6 times radical 6, the 6 is going to come out of prison. Even though he's still in prison, he's in the top floor. He's not in prison where the rats are. And so make that rat look more evil. And so this is called the simplified radical form of 5 radical 6. The next example I had on the paper was 6 over radical 2. The 2 cannot come out of prison. He doesn't have a lawyer. But if we multiply by a very special form of 1, which in this case is going to be square root of 2 over square root of 2, kind of what I'm doing is I'm finding him his lawyer. Okay, I'm calling his lawyer into prison. He cannot come out of prison, even though there's rats down here. So being kind and benevolent, we call him his lawyer. We multiply by some form of 1. The numerator has 6 not in prison, but 2 is. The denominator, square root of 2 times square root of 2, the 2 gets to come out of prison. And we're going to say that this is not our final answer because we can reduce this we can cancel people even if they're not inside prison. Okay, we can take 6 and divide it by 2, but this guy's still in prison, and we get our answer simplified to be 3 radical 2. And again, the calculator should be able to do this. Let me pull up my calculator again. I want to try 6 divided by the square root of 2 in my calculator and see if it gives me the answer it's supposed to give me. simplify it. Let me see if my calculator is smart enough to do that. So I've got 2. I've got a fraction key on my calculator, so I'm going to use a fraction key. Square root of 6. And I'm going to push the blue, this execute key. And it gives me the answer of radical 6 over 3. Is that what I got? Oh, sorry, 6 over square root of 2. Okay, so no, that's not what I got. 6 over square root of 2. Let me try that one. Let me do the right problem. Six, fraction key, shift square root of 2, giving me my simplified answer of 3 radical 2. So the calculator will take care of many of those problems. If you would like to make that into a decimal, you can't, because square root of 2, remember, is an irrational number. But you can, on this calculator, go from take that answer and make it into a decimal by putting this answer. That is only a decimal approximation of how many decimal places? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is called an irrational number, even though it's a decimal, because it does keep continuing on. It's not terminated, it's not repeat. So this is a decimal approximation for it. And one thing you're going to find in my class is I never want those decimal approximations. I want your answer in exact radical form. I think I can get it by using this again. Yes, by using that key again. So that's kind of like a nice fraction for those of you who love decimals. Okay, you're not in the correct class, because I'm not a person who, I like preciseness, and the preciseness here is in the beauty of that radical. Let's do a couple more examples to see what else we might encounter in our pre-calculus course. Here are all my drawings. What if we ended up with 16 in the numerator and a 20 in the denominator of our huge prism? If we've got a denominator here, what we could do is reduce our fraction first. But that might be the way I'll do this. I'll make this 16 into 4 times 4. So he has his lawyer, so technically he can come out of prison. However, since 20 can be factored into 4 times 5, I can see that I can reduce my prison population, because 4 divided by 4 is 1, or I just cancel them out. Unfortunately, that still leaves me somebody in the denominator where the rats are. And so what I'm going to do to simplify this further is to go 4 is 2 times 2. But I still have that pesky 5 in the denominator. Well, what I'm allowed to do is call a lawyer. So what I'm going to do is I'll actually put one big square in. Okay, I'm going to put 5 over 5. So now everybody's in prison. What a waste of taxpayers' money. Let's go ahead and put it's all in the same prison. We have 2 times 2 times 5 in the numerator. If you look real carefully, we have 5 times 5 in the denominator. I made that a little bit too large. I don't need my radical way over here. Let me see if I can do this. Whoops. I'm supposed to erase that. It's been a while since I've been on. Let me erase this all. one large prison, but not as large as it was. So now I have 2 times 2. I have my 5. I have my 5 times 5. So who gets to come out of prison? This 2 has a lawyer. He gets to come out of prison as a 2. This 5 has a lawyer. He gets to come out of prison, but he's going to come out in the bottom floor of the basement. This 5, who was in prison on the bottom floor and is not allowed to be in the, because we don't want to deal with anybody who has to stay in the prison because of the rat situation. That 5 happens to be actually in prison, but he's on the top floor. So again, there's lots of different ways to approach this simplification, but somehow this prison system just always worked when I was teaching, and we get away from it in our pre-calculus course because it's something we expect you to be already able to do. I'm going to do one more example for you because I have the time, if you have the time. What if you have 8 over square root of 2? He cannot come out of prison. He doesn't have a lawyer, but because of the rats down there, we're going to multiply by 1. The 1 I'm going to multiply by is radical 2 over radical 2. And again, you can call this square root of 2 over square root of 2 if you're really used to be calling it square roots. In the numerator, I have 8 radical 2. 8's not in prison, but the 2 is. And this 2 and that 2 are in the same prison. He gets basically to come out. He's got his lawyer. And this can be reduced. 8 over 4 reduces to give you what's called 4 radical 2. This is called multiplying by the conjugate in mathematics. And I kind of like the way that my prison system fits into this, because the first 3 letters talk about a con. And right now I'm dressed as an ex-con. If I talk about, let's say, 1 over the square root of 3, again, I never want to leave a square root in a denominator. I never want to leave somebody in prison. So I'm going to multiply by some form of 1. That's all I'm able to do. And so in rationalizing this, I end up getting, look, the word rationalizing has the word rat in it, okay? So by some divine intervention, all this sort of fits together with all the vocabulary, rationalizing a denominator. So that's right, rationalizing. And there's my rat. You've got a square root of 3 in the numerator, and you'll get 3 in the denominator. Multiplying by the conjugate is actually a little bit different than that. This is called rationalizing the denominator. Rationalizing by a conjugate is going to occur in a situation like this. And I'm just making some of these problems up. Let me see. In this situation, I've got 2 people in prison in the bottom floor separated by an operational plus sign. And I cannot just multiply the numerator and denominator by square root of 3, because that might pull this guy out of prison. But when I multiply, it's by using the distributive property, I have to multiply him, this radical 5, times that radical 3, which is giving me a radical 15. So that does not help the situation in what's called getting everybody out of prison on the bottom floor. So in multiplying by what's called multiplying by the conjugate, we're going to take this term, which is basically a binomial, and we're going to multiply by the radical 3 and a radical 5, but we're going to multiply, we have to do the same thing in the numerator. And we're basically multiplying this quantity times that quantity. And we'll worry about that numerator later. Okay. He's in prison. They're in the bottom floor. Okay, so here we go. Not going to worry about the numerator right now. I've got the square root of 15 on top. What I'm worried about is, did I get everybody out of prison on the bottom floor? So this is my numerator. Again, this is called multiplying by the conjugate in order to get the 3 out of prison. We're going to distribute the square root of 3 times the square root of 3 is the 3 gets to come out of prison, square root of 9. We multiply this radical 3 times this radical 5. That's a waste of taxpayers' money, but it's a negative radical 15. We multiply this positive radical 5 times this radical 3 by, again, using the distributive property, multiplying everything here by everything here. We get a positive radical 15. And this positive radical 5 times that negative radical 5, the 5 is going to get to come out of prison, but it's going to be a positive times a negative. It's going to be a negative 5. So by multiplying by what's called the conjugate, which is, again, the same binomial, just with an opposite sign, do you see how there are no more radicals in the denominator? Which works really nicely. My denominator then just becomes 3 minus 5, which is a negative 2. And the numerator, I still have a mess on the numerator. I have to take the square root of 15 times the square root of 3. I have to take the square root of 15 times the square root of 5. That's 15 times 5. And again, I could multiply these out to get 75, but instead what I'm going to do is I'm going to go ahead and just do my prime factoring. I'm going to, since I'm running out of space on this whiteboard because I'm writing so large, well, this is a large problem. I'm going to make this 5 times 3 times 3. I'm going to make this 5 times 3 times 5. And I'm going to see who gets to come out of each individual prison. I can't call this a waste of taxpayers' money because of that subtraction sign there, but who's coming out here? The 3 will come out of prison. Let me put my answer up here. I will have 3. The 5 will stay in prison right there. Subtraction sign. Who gets to come out of prison here? A 5. Who stays in prison is the 3. And in my denominator, I have a negative 2. You're going to find out in my class that I do not like to leave negatives in denominators of fractions. And so I would not have this, and neither would the textbook have this answer with a negative 2 in the denominator, but it is what I have. 3 minus 5 is negative 2. So what we normally do is multiply by 1. And in this case, my special multiplication by 1 would be negative 1 over negative 1. What that does is it doesn't give you a denominator with a negative number. It gives you the denominator of a positive 2, but it multiplies the numerator by negative 1, which would leave me a negative 3 radical 5. I do a double negative here, plus a 5 radical 3. These are not like terms. This is a 5 in prison. This has a 3 in prison. So this is basically my final answer. But again, I like to write my positive numbers first rather than that little, is that a negative? Did I really put a negative there, or is it just a mark on the paper? I would write this as 5 radical 3 minus 3 radical 5 all over 2. So I think that's all I really have to do right now in order to do some simplification. No, let me go a little bit further because this is going to come up later on in the course anyway. It's not part of this curriculum that I've got for my notes, but I want to talk about the square root of, let's say, -9. We have been taught that you can't really take the square root of negative numbers, and that is correct because this is an irrational number. Remember that mermaid that's on your number system page in the notes. But what we can do is make this -1 times 3 times 3. Then the 3 gets to come out of prison because he has his lawyer. The square root of -1 remains in prison. Well, a man named Jerome Cardan, a mathematician, said, we know we can't take the square root of negative numbers, but let's just pretend for a moment that I happens to be, little I, happens to be the square root of -1. We could write our final answer as 3i, and that's okay. We can go ahead and do that. But we have to say that this I pretty much is going to be what's called a complex number. But many people call it imaginary because of the little I, which doesn't really stand for imaginary. I stands for the square root of -1. So if we want to take the square root of, let's say, negative 27, we factor the -1 out. We have our 27, which can be dealt with our normal prison system. And I'll just do prime, I'll do 3, 9 times 3. You can see that this 3 has his lawyer, so he can come out of prison. The square root of -1 is going to now be called little I. Thank you, Jerome Cardan. And this 3 stays in prison. And so our final answer for simplifying the square root of -27 will be 3i radical 3. So it gets into a whole new world of what are we going to do when we have the real and the imaginary meeting. And this can get so exciting. What happens if we have the square root of -1 times the square root of -1? Well, going back to my prison system, if I put them both in the same prison, then he has his lawyer and he gets to come out of prison. And he does. The square root of -1 is I. The square root of -1 is also I. And so in the case of Jerome Cardan is introducing us with respect to i's, we're going to say that I squared is a -1. So as long as you have a lawyer, going from the imaginary, we're back to a real number, which is kind of scary thinking that those two number systems can actually coexist. We also have one more thing I'd like to go ahead and add here. If you're done, you're done. You can always come back to this. But what happens if I give you, let's say, a 3 plus I? This is going to come up later on in our class. So if I have a 3 plus I, and I want to multiply it by a 3 minus I, let's say this is our problem. We're going to go ahead and multiply this using the distributive property. 3 times 3 will be 9. 3 times -I will be -3i. Distributing these two together, you get a positive 3i. A positive times a negative is a negative. I times I, which is I squared. These cancel out. I squared is a -1. Got a song for that. I squared is a -1, pardon not knowing what he'd done. Some people started squaring it, not knowing what it was, but we'll continue squaring it forever till we know that I squared is a -1. So our final answer here would be 9 plus 1, which is 10, which is kind of scary that I took two what are considered to be complex imaginary numbers, because this is a real number, this is a counting number actually, and here's an imaginary number. I multiplied them together and I ended up getting a counting number. You know, things are crazy. It doesn't have to always be that way. I'll just do one more example. I can't stop here. Let's say I have 5 minus I, and I want to multiply that by 2 minus I. Got a real number, got an imaginary number, and I'm distributing here. 5 times 2 is 10. 5 times a negative I is -5I. And again, I'm kind of doing the first, outer, inner, last. Here's the first, F. Here's your outer, O. My inner here, -2I. And my outer, my last, I'm sorry, the -I times the -I is a positive I squared. This is 10. These are like terms, a -5I and a -2I happen to be -7I. And I squared is a -1, pardon not knowing what he'd done. Some people started squaring it. We add our like terms together. 10 minus 1 will be 9. 9 minus 7I. Again, you could call this an imaginary number, but most of the time in higher level math, we actually call this a complex number. Complex because it has not only a real component, but it has an imaginary component. So you could call this an imaginary number if you'd like, but we actually call them complex. And we're going to be doing that in chapter 4. So I hope that helped a little bit for those of you who had a little bit of difficulty with simplifying radicals. And if not, thank you for your time anyway. Bye. Comey out.